Assalamualaikum warahmatullahi wabarakatuh. My name is Nu'aina Fakiha binti Muhammad Kamal. So today I will demonstrating how to build a LabVIEW program for a tank system. We will start by creating the front panel, setting up the indicators, and then moving to the block diagram to organize the process using a case structure. The first part will focus on the fluid flow system, where we design the logic for the true cognition inside the case structure. By the end of this video, I will understand set up the interface and how the flow system operates within it. First, we need a pop-up at program start to ask the user for safety limit. So we add prompt user for input, configure the prompt to request temperature max and heat max with unit. Then we add numeric indicators to show the maximum temperature and maximum heat returned by the pop-up. Label them temperature max and heat max. Then add a tab control so the user can switch between the fluid system and the thermal system. Then inside the thermal system, we add capacitance, resistance, temperature input, and initial temperature, and thermometer. And add a digital display for thermometer or readings. Inside the fluid tab, add input control for magnitude, initial heat, resistance, and also capacitance. Also, we need to add a tank indicator and a digital display for readings. I also add a horizontal switch for the select input type T and select input type F. Select input type F for fluid system, while select input type T for thermal system. Select input type T, set left step, while right and pause. Go to the block diagram and add a case structure. Add a case structure controlled by the tab control so we can separate fluid and terminology. Put the fluid case inside a while loop so it runs continuously. Please wait and set it to 200 milliseconds so the UI updates every 0.2 seconds. Wire the select input type F to the key structure. Now, I will build the fluid mathematical model for both step and impulse input cases inside the fluid case. I add, divide, multiply, and add the true key structure for the fluid system. I also add reciprocal, exponential, and arithmetic equation and choose multiply. Add an elapsed time express I to provide T for the dynamic equation. Also, we need to add a reset button on the front panel to reinitialize time and state. From the elapsed time, we wire it to the key structure and add a constant for 10,000. And also add the greater comparison function and wire it to the 10,000. And then following to the fourth key structure, I also add multiply, divide, exponential, and etc. And then I add the reset button. And change it to the reset time. And then I go to the thermal system. I add the second key structure inside the thermal system. I also divide into the true key structure. Also integrated comparison, but this time we set the constant for 20,000. That's all for part 1. I have successfully created the user interface, set up the key structure, and computed the logic for the flow system under the true condition. In the next video, part 2, I will continue with the system and complete the rest of the formula.